Hello, in this session we will discuss how to convert decimal to hexadecimal number system. In the previous videos we have already seen how to convert decimal to binary. We have already seen how to convert decimal to binary, and the method we used there was divide by 2 method for the integer part, and for the fractional part it is multiplication by 2 method. Similarly, we have also seen how to convert the decimal to octal number. So what was the method? We used divide by 8 method for the integer part and multiply by 8 method for the fractional part. Similarly, here also for the integer part, for decimal to hexadecimal conversion, for the integer part we are going to use divide by 16 method for integer part, and for the fraction part we are going to use multiply by 16 method. The same concept used in the case of decimal to binary and decimal to octal. So we will see an example. First we will look at just an integer number, decimal number 78. Let it be the example, 78 to the base 10. We have to convert this 78 to the base 10, and the given number is decimal number. We have to convert it to the corresponding hexadecimal number. So we will take 78 divided by 16. So when we divide by 16, we will get 16 into 4. 16 into 4 is equal to 64. 16 into 5 is equal to 80. So that we cannot use. So 16 into 4 is equal to 64. So the remainder is 14. So the remainder is 14. So again we have to divide by 16. So we cannot divide 4 by 16. So 0 times 16 is 0 and the remainder is 4. So these are the answers. But here there is a problem. This 14 is a decimal number and not a hexadecimal number. Actually we want to convert to hexadecimal number. So what is the hexadecimal of 14? We have to rewrite it to the corresponding hexadecimal number. The hexadecimal of 14 is E. Hexadecimal of 9 is 9. Hexadecimal of decimal 10 is A. Then B, then C, D, E, F. So 14 is E and 15 is F. So the final answer. So we have to write from bottom to top. In the division method, we have to write from bottom to top. So the final answer, 78 to the base 10. 78 to the base 10 is equal to 78 to the base 10. That is the decimal number. This is equal to, first we have to write the last remainder. So that is 4. And finally the first remainder, that is E. That is 4e to the base 16. This is the final answer. So now we will see another example with a fraction also. So we will look another example. So just suppose take the number 91.261 to the base 10. So we have to convert this to corresponding hexadecimal number. So first we will take the integer part 91. So to convert this 91 to corresponding hexadecimal number, we have to divide it by 16. So 16 into 5 is 80. 16 into 4 is 64. 16 into 5 is 24 and 80. So the remainder will be 11. 16 into 5 is 80. So the remainder is 11. Since 11 is not a hexadecimal number, we have to convert it to hexadecimal. Because 10, the number greater than 9, that is 10, 11, 12, 13 and 14. Sorry, 10, 11, 12, 13, 14 and 15. These three numbers have to be rewritten as A, B, C, D, E and F. So 11 is B. So the remainder is B. So again we have to divide this 5 by 16. So it will not, we cannot divide it. So 0 times 16 is 0 and the remainder is 5. So 96 to the base, 91 to the base 10. 91 to the base 10 is equal to 5d to the base 16. So always we have to write the last remainder first. Then we have to move upwards. So if you are not familiar with this successive division method, go and watch the previous videos. Conversion of decimal to binary. It is clearly explained how we should do this successive division method. So this is the answer of the integer part. Now we will see the fractional part, that is 261 to the base 10. So we will see the fractional part. So I will write the fractional part here. So that is 0.261 to the base 10. So here we are not going to use successive division, we are going to multiply with 16. That means, so to convert this to corresponding hexadecimal, you have to multiply it with the 16. That means 0.261 into 16. So that is equal to, we will use the calculator, 0.261 into 16, 4.176. That is 4.176. So we have to write down the integer part separately. So we will write 4 here, and we have to take this resultant fractional part again and we have to multiply it. That means 0.176 into 16, that is equal to 0.176 into 16, 2.816. 2.816. So here also we have to take this integer part and write it separately. And now we have to take this fractional part and multiply again it with 16. That means 0.816 into 16. So that is equal to 0.816, sorry, 0.816 into 16, 13.056. That is 13.056. So we have to again take this 13 to here. Actually, earlier I already told you 13 is not a hexadecimal number, so we have to convert this 13 to corresponding hexadecimal. So 13 is D. 13 is D in hexadecimal. So this process will continue. Again, you can take this fractional part and multiply by 16. You will get something. Take the integer part. Again, take the fractional and multiply, and this process will continue. We will stop once we get the fractional part as 0, 0, 0 something. If all the fractional part are 0, we will stop. Integer can be anything. Integer can be any number. Integer part can be any number. But the fractional part, when it reaches 0, we will stop multiplying by 60. So in some cases like this number 0.261, it may not stop. It will go repeatedly again and again. So we can stop with 3 or 4 numbers. So here how we will write the answer: 0.261 to the base 10 is equal to, we have to write from top to bottom. In the division method, we have written from bottom to top. Here we have to write from top to bottom. So that is 4 2d to the base 16. So this is the answer. So the final answer is, that is 91.261 to the base 10 is equal to 5b.42b to the base 60. So this is the final answer. So this is how we convert a decimal to hexadecimal number. So now we will look how to convert a binary number to hexadecimal number. Converting binary to hexadecimal. So to convert binary to hexadecimal, it is quite easy. So we will write an example. So consider the binary number 111011011. Suppose this is the binary number. So to convert, what we have to do is just group in terms of 4 from the right side. Just group in terms of 4 from right side. So from the right side, this is a group of 4 bits. Again, this is a group of 4 bits. The last group may have less than 4 bit or it may have 4 bit. If it is less than 4 bit, leave it as such. So the answer is 1011. 1011 is 11. In hexadecimal number, 11 is D. 1101. 1101 is 13. In hexadecimal, it is D. 13 is D. And finally 1. It is 1. So the final answer is, sorry, I haven't written the base here, 11101101 to the base 2. So that is equal to 1 B to the base 16. So this is the answer, and this is how we convert binary to hexadecimal number. So this is quite easy. If any binary number was given to you, what you want to do is from the right side group in a bit of 4 bits and write the corresponding hexadecimal number. So we can check one more example. So consider the number 101101. So from right side group in terms of 4. So here we have only 2 bits, leave it as such. So the last group may contain 4 or less than 4 bits. So that's not a problem. So the answer is 1101. Again, it is 13. So it is D. And 10 is 2. So the final answer is 2D to the base 60. And this is of base 2. So this is how we convert binary to hexadecimal. And finally, we will check how to convert octal to hexadecimal number. How to convert octal to hexadecimal number. Octal to hexadecimal number. Again, this is also quite easy. The method of converting octal to hexadecimal. So again, we are using binary number here. Suppose there is a octal number, it is 37 to the base 8. So we have to convert this to the hexadecimal number. So in order to convert 37 octal to hexadecimal, we make use of the binary in between. So 37 octal number is first converted to binary. So that is 7 we have to write in 3-bit binary. Just if you are not familiar with octal to binary conversion, go to the corresponding video in the playlist. So that is 111. You have to write in 3-bit to convert octal to binary. So this is 011. So this is the answer, 011111. So now how to convert this binary to hexadecimal? Just now we have seen that So just group in terms of 4 from the right side, we can easily convert binary to hexadecimal. So in this case, these 4 numbers are a group and remaining 2 is another group. So the final answer is 1111 is 15, that means F, and 01 is 1. So the final answer is 37 to the base 8 is equal to 1f to the base 16. So this is quite simple. So this is how we convert other number systems to hexadecimal number system. So we have seen at the starting, we have seen how to convert a decimal to hexadecimal. For the integer part, we are doing division by 16, and for the fractional part we are doing multiplication by 16, and we will stop once all the fractional part reaches 0. If it is not reaching 0 and the multiplication is going on, we can stop after 3 or 4 places. And next we have seen the binary to hexadecimal conversion. Again, it is very simple. Group in a bits of 4 from the right side, we can and write the corresponding hexadecimal number. So this is also quite simple. And in the case of octal to hexadecimal number, we use binary in between. So first convert the octal number to the binary number, and then group that binary number in a group of 4 bits from the right. So we will get the corresponding hexadecimal number.